Hello children, in this session we will be discussing about the very important concepts of refraction is that principle of reversibility, and we will be discussing about refraction through a glass slab. Children, especially refraction through a glass slab is a very important, it is very useful when we will be discussing the refraction through a lens. Very important. There one important concept we will discuss is that whenever a light passes through an optic center of either concave lens or convex lens, it will go undeviated. So why it will go undeviated? So for that, actually the basic reason is what actually you have to understand is that refraction through a glass slab. When you can understand the refraction through a glass slab, that point will become very clear. So children, before going to start today's session, let us recall what we had discussed in a previous session. Children, in previous session we discussed some basic concepts of refraction. Children, let us recall once again, what is a rarer medium, what is a denser medium? I mean optically denser medium and optically rarer medium. Children, optically denser medium and optical rarer medium is discussed, is defined in terms of speed of light. Children, what is a rarer medium? Think once again, what is rarer medium? So here, the medium in which light travels faster when you compare with other medium is called optically rarer medium. Then what about optically denser medium? Just you think, it's quite opposite. What is that? The medium in which light travels slower when you compare with other medium. So it's a very important thing is that unless and until you compare, we cannot decide whether it is given medium is a rarer medium or optical, that is optically rarer medium or optically denser medium. So this point is a very important. And after that we discuss during a refraction what quantities will change, especially during refraction, speed will change, wavelength will change, intensity will change, but frequency remains constant. It's very important. Then dear children, Snell's law of refraction we discussed. Snell's law of refraction. Once again, just let us recall, dear children. Here, for suppose here is a separation between the two mediums. Let us say, dear children, it is medium 1. It is a medium 1, and here is medium 2. Medium 2, and here this is a normal drawn. For suppose if a light is coming and incidenting like this, so that here is a angle of incidence. So if it is a rarer medium, let us say here is a denser medium. Obviously, what will happen? Light will move towards the normal, so that here is an angle of refraction. So let us say here the refractive index of first medium is a mu1, the refractive index of second medium is a mu2. Children, it's very important. This point is very important to understand the principle of reversibility. So then according to Snell's law of refraction, how can we write it, children? The refractive index of second medium with respect to first medium. This is very important. Refractive index of second medium with respect to first medium means always we have to take the refractive index of the medium in which refraction is occurring with respect to the other medium. With respect to the other medium, which is equal to sine of angle of incidence to the sine of angle of refraction. So this is Snell's law of refraction. It's very important. So the refractive index of second medium with respect to first medium is equal to the ratio of sine of angle of incidence to the sine of angle of refraction. This point we have to remember in order to understand the principle of reversibility. And after that, even we discussed about refractive index, dear children. So refractive index, what we discussed? It is the ratio of speed of light in a vacuum to the speed of light in a medium. This is also very important. Based on this, so based on this and based on this, we can expect the numericals. Okay, children, fine. And what is today's topic? As I said that today we are going to discuss the principle of reversibility. So with this concept, children, again I am saying you, in order to understand the principle of reversibility, the concept of Snell's law of refraction is very important. Now let us discuss what actually principle of reversibility, and after that we will be discussing about the refraction of light through a glass slab we will see. So now let us start today's topic, principle of reversibility. Principle of reversibility. So dear children, according to principle of reversibility, what does it state? So what actually principle of reversibility? So children, according to principle of reversibility, the path of the light ray is reversible. Very important. The path of the light ray is reversible. Very simple. Children, the name itself will give you the concept. Reversibility means what actually? Reversing means when we reverse the direction of light, dear children, its path is retraced. It's very important. So very important thing is that, children, Now, how to understand this? What is the so-called reversibility? Children, let us take a case of plane mirror. Let us take a case of plane mirror. For suppose, if the light is coming and incidenting perpendicular to this plane mirror, then what will happen after reflection? Its path is reversed. This is actually reversibility. This is what actually reversibility. But we will see this in the case of refraction. So, how the path of light ray is reversible? Look at here, children. So, for this, let us consider here is a separation like a, separation between the two mediums. Let us say here is medium 1. Let us take here is medium 1 whose refractive index is mu1, and here is medium 2. It is medium 2 whose refractive index is mu2. Here xy is a separation between the two mediums, children, and here is normal drawn. Let us say here is n is a normal drawn to the surface, such a way that now light is moving from first medium to second medium. First medium to second medium. So, let us say here mu1 is less than mu2. Mu1 is less than mu2, which means what is children? First medium is a rarer medium and the second medium is a denser medium. Children, if there is no second medium, what would happen? Light would have traveled along a straight line path like this. So, light would have traveled like this in a straight line path. But what happens, dear children, as light is moving from rarer to denser medium, it slows down, due to which it will move towards the normal. This is how it will get refracted. This is how actually it will get refracted. So, this is angle of incidence and this is angle of refraction. Now, dear children, for the sake of our convenience, let us take angle of incidence as theta 1, okay, whereas angle of refraction as a theta 2. Now, dear children, let us apply Snell's law in this case. Already we discussed what is Snell's law. Let us recall. So, the refractive index of second medium with respect to the first medium is equal to the ratio of sine of angle of incidence to the sine of angle of refraction. So, according to Snell's law, dear children. So, now let us apply Snell's law. Apply Snell's law for xy. For xy boundary we are applying. So, let us take the case 1, children. It's very important. Let us take the case 1 where light is moving from medium 1 to medium 2, children. It's very, very important. Light ray is moving from medium 1 to medium 2. Now, in this case, what is the angle of incidence? Theta 1. Children, here, angle of incidence is equal to theta 1, whereas angle of refraction is equal to theta 2. Now, let us apply the Snell's law of refraction. According to Snell's law of refraction, the refractive index of second medium with respect to first medium, that is, we can write mu 2 1, or children, we can write like this also, mu 2 by mu 1. Refractive index of second medium with respect to first medium is equal to sine of angle of incidence. Angle of incidence is how much? Theta 1. It is theta 1 and it is sine of angle of refraction. Angle of refraction is how much? Theta 2. It is theta 2. Now, let us say it is the case 1. Clear, children? So, what we have done? We have done, means new thing, anything we have not done. It's nothing is done here. New thing is not done at all here. What we have done simply, just we have applied Snell's law of refraction. Snell's law of refraction. Now, what are we going to do is that, dear children, for this, the path of the refractor ray is like this, it is going. For that path, let us keep one plane mirror perpendicular to its path. Perpendicular to its path. Very, very important. Perpendicular to its path. Now, what will happen if light strikes perpendicular to the mirror, children? It's 90 degrees. Perpendicular to the mirror. What will happen? Its path is retraced. Its path is retraced. Means what will happen now in this case? Light is moving from like this, its path is retraced. So, this is how light will be going. As it is, it will go. So, its path is retraced. Now, this is how light ray is moving. So, try to understand. Here, now what are we doing actually? So, here we are keeping one plane mirror perpendicular to the path of the refracted ray. Then what happens? Its path gets retraced. Its path gets retraced. Means the way how it was coming previously, the same way it is going now. That is what actually principle of reversibility. The path of the light ray is reversible. The path of the light ray is reversible. Now, in this case, light is moving from second medium to first medium. So, it's very important. Now, look at here. This is what we will take as a case 2. We will take as a case 2 where light ray is moving from medium 2 to medium 1. So, it is very important. Now, let us apply Snell's law. But dear children, here one important thing which we have to notice. What is the angle of incidence here? In this case, theta 2, because light is like this, it is going. Light ray is going like this. So, now this will become incident ray. So, theta 2 will become angle of incidence in this case. Children, very, very important. So, in this case, angle of incidence will become theta 2, whereas angle of refraction will become theta 1. Children, this is what we have to notice. Try to understand. In this case, what is happening here? As we are putting the plane mirror perpendicular to the path of the refracted ray, its path is retraced. Now, in the second case, you imagine, dear children, the light is going from medium 2 to medium 1. So, theta 2 will become angle of incidence, theta 1 will become angle of refraction. Now, let us apply the Snell's law. As light ray is moving from medium 2 to medium 1, so here refractive index of this medium now, because in which refraction is taking place? In the first medium, refraction is going to take place. So, here we can say the refractive index of first medium with respect to second medium is equal to, this can be written as mu1 by mu2 is equal to sine of angle of incidence. Now, angle of incidence is going to be theta 2. So, that is sine theta 2 by sine of angle of refraction, that is a theta 1. Let us say it is a equation 2. So, children, so here we got equation 1, equation 2. Now, let us see here. Let us here. So, I think we can rub this diagram. Hope you have copied this. Yes. Let me erase this. Fine. Now, let us see, dear children. So, what can we do is that from 1 and 2, from 1 and 2, look at here. So, what can we do? Look at here. So, we will do like this. First equation, we are multiplying with the second equation. I mean, LHS should be multiplied, RHS should be multiplied. Look at here. So, it is going to be mu 21 into mu 12 is equal to. So, mu 21 is nothing but sine theta 1 by sine theta 2. That is sine theta 1 by, it is sine theta 2 into mu 1 to 2 is what, children? Sine theta 2 by sine theta 1. This is sine theta 2 by, here is sine theta 1. So, if you can see here, sine theta 1 get cancelled, sine theta 2 will be get cancelled. So, here what we got here, mu 2 to 1 into mu 1 to 2 is equal to 1, or we also can write like this, or it can be written as refractive index of second medium with respect to first medium is always equal to the reciprocal of refractive index of first medium with respect to second medium. So, based on this, dear children, we can expect 1 mark questions we can expect. So, how the questions are asked? Let us see one example. Children, the example this thing is that very, very simple. It will be given like this. The refractive index of water, or else let us say the refractive index of glass, let us take. Glass is, for example, the refractive index of glass with respect to air is 3 by 2, is given 3 by 2. Then find the refractive index of air with respect to glass, Children, look at here. The refractive index of glass with respect to air is 3 by 2. Then it is asked to calculate the refractive index of air with respect to glass. Children, can you try? Just try it. Just use the concept. This concept you can use it. Just try it. What is the answer which you are going to get? Got it? Comment your answer. Okay, fine. Let us see here. Very simple thing. So, according to principle of reversibility, can we write like this? Refractive index of air with respect to glass they are asking. Refractive index of air with respect to glass. So, according to principle of reversibility, it can be written as a reciprocal of refractive index of glass with respect to air. Got it? This value is given. Look at here. Refractive index of glass with respect to air is 3 by 2. So, this is going to be 1 by 3 by 2. This will be 2 by 3. That's it. So, this is a refractive index of air with respect to glass is equal to 3, sorry, already 3 by 2, say 2 by 3. 2 by 3, it can be 0.66 something you can get. So children, so this is how actually we can do the very simple numericals based on principle of reversibility. So this is what actually principle of reversibility. So it says that the path of the light ray is reversible. Okay, fine. Now we will discuss the very important thing is what? Refraction through a glass slab. So this is very important. So refraction through glass slab. Refraction through glass slab. Refraction through a glass slab. So children, so what type of glass slab we are going to consider? So we are going to consider rectangular glass slab. Let us take here. So here is, let us take here is a rectangular glass slab. This is rectangular glass slab, let us say. So let us name it as A, B, C, D. So children, before that, let us recall once again, what happens when light moves from rarer to denser medium? Children, what happens when light moves from rarer to denser medium? It moves towards the normal. I mean, it bends towards the normal. But whereas, when light moves from denser to rarer, what happens? It moves away from the normal. But dear children, as long as the light is moving in the same medium, what happens? It will maintain a same path. So the path won't get deviated. So these are the points which we have to keep on our mind so that this concept will become very easy. Okay, chalo. So here A, B, C, D is a rectangular glass slab. Now let us consider, dear children, here is light ray. So let us say is PQ is an incident ray. So let us say is PQ is an incident ray. At this point it is incidenting. So at this point let us make a normal. So here is, this point is going to be the normal. This point is going to be normal. Children, here if there was no glass slab, then what would happen here? This light would have traveled in a straight line path. So this is the original path of the light ray. Let us say PQ some XY. PQ, let us name it as some XY. So PQXY is the actual original path of the light ray. Here at this point it is incidenting, so that this is angle of incidence. Fine. Now dear children, don't you think that this is air and here is a glass, again it is air. Now from where to where light is moving? From air to glass, that is rarer medium to denser medium. Children, whenever light moves from rare to denser medium, it slows down, due to which what happens? It moves towards the normal. It bends towards the normal. So look at here. So instead of going a straight line path, it bends towards the normal and it will travel like this. Why it is going along a straight line path inside the glass slab? Because the medium is same. As long as the medium is same, light can travel in a straight line path. So this is refracted ray. So that this is, children, angle of refraction at a first surface. Angle of refraction at a first surface. Now at this point, again what is happening here? Light is moving from glass to air, which means what? Denser to rarer medium. So whenever light moves from denser to rarer medium, what happens, children? It moves away from the normal. Why? Because it speeds up. Acha. So here let us make a normal. Fine. Then what is angle of refraction? This is going to be angle of refraction. Acha. Then what happens? Going from glass to air, it moves away from the normal. So it moves away from the normal. So let us name it as a RS. RS is an emergent ray, and the angle between emergent ray and normal is called angle of emergence. Angle of emergence. So children, this is how light ray will get emerged out when it passes through the prism. So here one very important thing which we have to notice. What is that? Just look at the emergent ray RS and original path of the light ray. What is happening here? Don't you think that both are parallel to each other? Yes, both are parallel to each other. Means what? What is happening means, so I'll tell you. For suppose here light ray incidenting with a 30 degrees. Light ray is incidenting with a 30 degrees. You know what will happen? With the same angle, it will emerge out. Which means what here? angle of incidence is always equal to angle of emergence. Children, it's very, very important. So here very, very important thing is that here angle of incidence is always equal to the angle of emergence, which means what here? Light ray is not deviated. So here glass slab does not deviate the light ray. It's very, very, very important. So in exam the question will be asked, what is the deviation produced by the glass slab? It's very important. Just note down here. Deviation produced by the glass slab is 0. The deviation produced by the glass slab is 0. Means here glass slab is not at all deviating the light ray, rather it is shifting the light ray parallel to itself. Means light ray had to go like this, but children, that light ray got shifted like this here. So this is the very, very, very important. Very, very important, children. What is that point? Let us recall here. What is the deviation produced by the glass slab? 0, which means what? Glass slab does not produce any deviation in incident ray. Then what it can do? Just it can shift. Acha. Children, here if you can notice here one very, very important thing is that there will be some perpendicular distance, am I right? Between this virginal path of the ray and the emergent ray. Look at here. So this we can highlight. So this is a perpendicular distance. Let me highlight this. So this is a perpendicular distance. Okay. So this perpendicular distance, let us LD. Let me represent with the LD. What is this LD so called? It is called lateral displacement. Children, next the very, very, very important thing is that lateral displacement. So here examination point of view, what is lateral displacement? What is lateral displacement and on which factors does it depend? On which factor does it depend? So very, 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 very important, children. So what is lateral displacement? Children, it is the perpendicular distance between what? Between emergent ray and incident ray when extended forward. Children, what is lateral displacement? The perpendicular distance between emergent ray and incident ray when extended forward is called lateral displacement. Actually, here very, 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 very important thing is that on which factors does the lateral displacement depend? Very, very important examination point of view. So, look at here. So, it depends on lateral displacement depends on the first one. Very, very important thing is that here angle of incidence. So here lateral displacement depends on angle of incidence. So how does it depend? So as the angle of incidence keeps on increasing, angle of deviation also, angle of emergence increases. As the angle of emergence increases, obviously lateral displacement also increases. Lateral displacement is very, very important. So here lateral displacement is directly proportional to the angle of incidence. And the second factor is that angle of lateral displacement, it depends on the thickness. For example, if you can you can imagine like a 3D, like a 3-dimensional, like this, if you can imagine. So this will become, so this will be the thickness, right? This is going to be small t, So thickness, so here the second factor is that lateral displacement depends on the thickness of the glass slab. How does it depend? So lateral displacement is directly proportional to the thickness of the glass slab, which means what? As the thickness of the glass slab increases, obviously lateral displacement also increases. Fine. The third one is that it also depends on the material. With what material it is made up of, or we can say even it is a refractive index also. So here lateral displacement is directly proportional to the refractive index. Very, very important. Children, in examination they will ask you for which color lateral displacement is more. Then you have to think for which color refractive index is more. For violet color. So for violet color, as the refractive index is more, obviously lateral displacement also more. Okay, and the fourth point is that color or wavelength. Color or wavelength of the light used. Wavelength of the light used, that is a lambda. So children, here lateral displacement is not directly proportional to the, it is a inversely proportional to the wavelength. That is what? More the wavelength, less the lateral displacement. Less the wavelength, more the lateral displacement. So in exam they may be asked the question, which of the following color will have less lateral displacement? If red color is given in that options, you have to pick up red color only. Why? For a red color, wavelength is more. So obviously the lateral displacement will be less for the red color. Then for which color? Children, for which color lateral displacement is more? So you have to think, for which color wavelength is less? Violet color. Acha. So here for violet color wavelength is less. So obviously for violet color lateral displacement is going to be more. Okay, fine. So this is how actually refraction takes place through the rectangular glass slab. And here what is the lateral displacement and the factors on which lateral displacement depend. So children, these are the concepts of unit A of the refraction of light at a plane surfaces. Now let us once again just summarize the concept, whatever we discussed in this unit. Let us summarize here. Fine. So the important topics, just once again let us summarize the children. So here first we discussed about the important topics. I am summarizing very important topics. So we discussed about refractive index. Here we got refractive index formula, mu is equal to C by V. And even we can use mu is equal to it is sin I by sin R. These two formulas we use to calculate the refractive index. And after that, dear children, what we can say, it's a relative refractive index. So the refractive index of one medium with respect to another medium. So how can we write refractive index of one medium with respect to another medium? This can be written as it is mu 1 by mu 2. And on which factor refractive index depends, children? Very important, it is refractive index depends on nature of the medium, and the second one is depends on the temperature. How does it depend? Refractive index is inversely proportional to the temperature. Next we discussed about the principle of reversibility. According to that, the refractive index of second medium with respect to first medium is equal to the reciprocal of refractive index of first medium with respect to second medium. Fine. And then we discussed about the refraction through a glass slab. Their very important thing is the lateral displacement. What is the lateral displacement? The perpendicular distance between emergent ray and virginal ray when extended forward is called lateral displacement. So on which factor lateral displacement depends? It's very important. Lateral displacement depends. So first one is lateral displacement is proportional to the angle of incidence. The second one is lateral displacement is proportional to the refractive index of the material of the glass slab, and lateral displacement is proportional to the thickness, and finally lateral displacement is inversely proportional to the wavelength or color. So children, these are the very important, I can say it's a summary. So based on this, mu is equal to C by V and a mu is equal to sin A by sin R, we can expect the numericals. Children, next class we will be discussing the refraction through prism. So in this session we discuss refraction through a glass slab. In the next class we are going to discuss the refraction through a prism. Okay children, thank you so much, all the very best.